What is this concept? This concept is equivalent figures. And welcome, my algebros, to another segment of. No? You're not doing that? All right. Very cringy. I'm going to start every time. Welcome, my algebros. That's the intro. You come up with something better, I'll change it. So, two rectangles have the same area. I like this one to start out because that is the most important statement that we can find. This concept is equivalent figures. So way near the end. So equivalent figures. Now I want to write down the steps. I have them on the board behind you, but in terms of this video, I'm going to write them out here in full. So step one is to find the. This is my own kind of terminology here. The equivalency statement. Okay. And what I mean by that, I'm just going to highlight it right here. Two rectangles have the same area. That's the equivalency statement. Because what it's suggesting is, and I'll write it next to it here, that area of one is equal to area of the other. I need that now because my process in this question, I'll skip down to the end, is to find a numerical value for x. So there's a way we can do it. With these questions, when they're done properly, you're going to be able to find a numerical value for x. So that's my first thing, finding that out. And the second step would be to find all the pieces and input them into your statement. So find and input all values. All values, or let's just say expressions, if you will. Right? Because sometimes it may be just two, like in this case here. So what is the area of a rectangle? It's length times width. What is the area of a rectangle? Length times width. Now let's read through the rest of the question. It says the first rectangle has a dimension of 2x minus 3 meters by x plus 1 meters. The second has dimensions of 2 meters by x plus 16 meters. What is the numerical difference in their perimeters? So, two most important parts of this question. Number one, equivalency statement. Number two, it's saying I need a numerical value. I need a real value. So that means I have to find a value for x. Okay. So I'm going to input everything. It's going to look like this. 2x minus 3 times x plus 1 is going to be equal to 2 times x plus 16. Looks pretty ugly. How the heck are we going to find a value for it? I have so many x's there now. Ugh, that's gross. Ugh, gross. Okay, so that is me inputting all the values right there. Any questions so far? Pretty self-explanatory. Okay. So step 3 is going to be expand and combine. Expand and combine. Okay. So if that's my approach, and the other term I use for this, and I used to use until last year, they made fun of me. I'm going to call it a monster mash because the reason why I call it that on this stage is because when I work this guy out, so expand means FOIL. I'm just going to do FOIL of this and then distribute that 2 throughout that. So then 2x squared plus 2x minus 3x minus 3 is equal to 2x plus 32. I call it monster mash because you're literally taking that ugly equation and turning it into 1. So it's not going to be, it should, by the end of it, be less ugly, kind of. Now, my advice to you here when I expand and combine, and you can kind of write this next to it if you want, is I like to keep a positive. As in, if you have a choice to move everything to the left side or everything to the right side, which you always do, I would basically say in this instance, let's move all of this over to this side and keep 2x squared as positive. Just because from here on in, we've got to do some factoring and stuff, and it's easier when a is positive and not negative. It's really just to make it easier on you. It's not right or wrong. It's just I feel it makes it easier on you. So 2x squared minus 3x, because I'm subtracting 2x from the other side and combining with negative x, and then negative 35 is equal to 0. If you get to here, I'm pumped, right? That's, my eyes just scanned the sheet for that. Okay, can you get to there? And then step 4 is we either factor, and I'm going to write this in here now just because it's going to come up and become apparent later on, factor or minus b plus or minus. You don't have to make this one perfect right now. You can write quadratic equation if you want. So just either write this or quadratic equation. You can see it bigger right there. Minus b plus or minus square root of b squared minus 4ac all over 2a. It's a mess. Here's a scenario. If I go to try and factor something, you know how there's been some questions where like, oh no, it's unfactorable. What do we do? If it's unfactorable, the quadratic equation will find a value. And when it's unfactorable, what it means is the value for x is going to be a decimal, right? If it's factorable, x is like 3, x is 5, x is something, right? But if it's an ugly decimal, it's likely got to be quadratic equation.
I'm just trying to read it. What does it say? Negative b what?
Negative b plus or minus. Can you see it up here better?
Oh, yeah.
Plus or minus square root of b squared minus 4ac all over 2a. And it's all over 2a. That's important, but we'll talk about it later. We're going to be practicing that this week too, I believe. We get the time. But for right now, I think most of these, we don't need that skill. So now I want to go ahead and factor this guy. So step 4 is going to be go ahead, right, and factor it. So we're not going to quadratic equation it in this instance. We're going to factor it. So what plus what is equal to negative 3, and what times what is equal to negative 70? What are my numbers there? Don't overthink it. Don't overthink it. What is it? So negative 10 and 7? Negative 10 and 7. So now it's just factoring, right? 2x squared minus 10x plus 7x minus 35. Don't forget that it's the original value on the end, not the a times c, not the Munchkin number. And then I'm just going to common factor 2x, x minus 5 plus 7, x minus 5. This should be automatic by now, doing this stuff. Now here's the last step. Okay. So I've gone through, just to reiterate, made my equivalency statement, put in all the values, all the expressions, expanded it, combined it all into one, and then factored it into 2 pretty pieces. So here's what happens is solve for x. There's a value in why we factor. So up to now, we just factored for the sake of making it pretty. Now, 2x plus 7 is equal to 0, and x minus 5 is equal to 0. You just take what's in the brackets and set them equal to 0 and solve for x. Literally, once you have the 2 nice pieces, you take the binomial and set it equal to 0. 2x is equal to negative 7. X is equal to negative 3.5. X is equal to 5. So here's what's weird. We're used to in the past finding one answer and one answer alone. Now we get 2, but only one of them is right. Okay? if this is a scenario where we're talking about dimensions, which one of these is the one that I'm going to reject? Which one would I likely reject?
2.5.
The negative 3.5. Because negative 7 divided by 2.
That's 2.5.
That'd be 3.5. Half of 7.
Wait, yeah, you're right.
Half of 5, 2.5. Half of 7, 3.5. So because this guy, so if you weren't listening right now, because I know you guys are frantically writing down, this guy right here is the one that I would reject. That's the one that I would accept. It does. The question does say, what is the numerical difference in the perimeters? We can get through to do that. I'll say this a lot this year. I don't want to add a hat on a hat right now. My main objective for today is, can you get through these 5 steps and solve for X? That's what our focus is today. We'll worry about what we do with that once we get it, given a different scenario, each different scenario. But for right now, that is an equivalency figure 1. So just as a review, find the equivalency statement in the text, put it down, write it out, expand it if you have to, combine it all together, factor it, and solve for a value for X. And so one's going to be accepted and one's going to be rejected. Okay? And now it won't always be that one is negative, but let's just say you found a value of X is equal to 10 and 22. And one of the expressions was X minus 16. Which one of those two would you accept? Which one would you reject? If I had X is 10 or X is 22 of my possibilities, but yet one of my original dimensions was X minus 16. You're going to accept 10 or reject 10? Accept 10? Let's try and plug these two in. 10 minus 16 would be negative 6. 22 minus 16 gives me a positive 6. So I'm going to take the one that's a positive 6, even though you threw that in there. Yeah, I know I heard that. I'm going to take in the positive 6 because at the end of it, right, I still want to get an actual dimension. So if I plug in a value to an expression and it spits out a negative number, then that won't fit this scenario. So I would go with the bigger one that would actually fit that. Other times it may be that the number is too big. It's something like the combined area is 36. You'll see that later on. And if you had two options of like X is 4 or X is 23, and it said the combined area is 36, pretty sure we're going to reject the 23 because when I plug it in, it's going to make it way too big. So there's all these different uses of logic to kind of decide whether or not I want to accept or reject values for X. But at least if you get down to those two, I'll be extremely happy. Any questions on that?